All right, so this is a nice picture I took once when I had an opportunity to visit NASA Goddard in Huntsville, Alabama. I want us to start from here just to get to know the feel of the audience. What is it that you know about Landsat? So I would ask you to get to menti.com and type in the code that is here, or you can use the QR code to get directly there. So I'll give you a minute, then switch to Menti. So I want to get us to Menti. So I will share another screen. Are you able to get what is on Menti, the question? Okay. All right, so seems like we have a mix of people, those who know nothing about Landsat or very little about it, and some who know quite some bit. So I hope that through this presentation, you'll be able to capture a little more. In the next slide, I want you to take the next question and let me know what you think we can use Landsat data for. So here we're getting a mix of responses. At least quite a number of people know that we use it for land cover change. But there's also quite a bit more that we use Landsat for. So we'll be getting into this, the responses that you have given, and a little more. So I want to stop this here and get onto my presentation. All right, so you guys know quite a bit. So I want to start with presenting my institution, which is the Regional Center for Mapping of Resources for Development. It's quite a mouthful for most people, but it is a center that has been here with us in Nairobi since 1975. It was established under the auspices of the UNECA and the then Organization of African Union. So it has lived through over 50 years of existence. And really what RCMRD looks forward to as part of our vision is to be a premier center of excellence in the provision of geoinformation and allied ICT technologies, particularly in support of our member states and also stakeholders beyond these member states. We work through different areas by providing our stakeholders with capacity building, application and dissemination of information in terms of utilizing technology. And I'll talk a little bit about this later in my presentation. In terms of our areas of operation, so I've mentioned that RCMRD has 21 member countries. So the countries in green, these are the contracting member states, and the ones in pink are the non-contracting member states. So basically, this just means that we have different agreements with these countries, and you can see we cover quite a big scope of region in terms of who to work with. So RCMRD is a well-known institution as far as geoinformation is concerned. Our core mandate spans across capacity development, data and information, advisory services, project implementation. We also do a bit of research and development and also provide services to our member states related to calibration of equipment. And this would be like a survey instruments in that case. So those of you who've interacted with RCMRD at one point or another may have been able to receive one of the services indicated here. Then I want to talk about the project that I work for, that is SAVIR Eastern and Southern Africa. So SAVIR itself is a joint initiative of USAID and NASA. Basically USAID because they support development activities globally, and NASA provides us with the scientific backstopping and knowledge sharing. So through this, we're able to work with scientists basically from all these hubs. So SAVIR itself is a global network of 5 different hubs currently. So we have in Africa 2 hubs, the hub in Eastern and Southern Africa serving the countries indicated. There is another hub in West Africa that serves about 5 to 6 countries. In Asia, we have another 2 hubs. There is the hub in the Hindu Kush Malaya, that is in Isimud, and there's another hub at ADPC that is serving the Mekong region. In the America region, we have the hub in Central America called the Savir Amazonia, and soon we'll be establishing another hub. And through the network, we also have support that we receive from USAID and NASA based in Washington, DC. And we also have the Savir Coordination Office that is based in Huntsville, Alabama. In terms of the service provision, so Savir works in 4 thematic areas, as indicated, agriculture and food security. And here we implement a number of activities ranging from agricultural monitoring, drought management, crop productivity, just to mention. There's the land use, land cover thematic area that I support. So this right from ecosystems, and also in supporting decisions related to RED, to greenhouse gas inventories, and also in land use decision support systems. Our third thematic area is water and related disaster. So again, this is another area that covers quite a number of topics, so ranging from floods to early warning systems, to water quality issues, hazards, as well as a forecasting of water resources. Then the last thematic area focuses on weather and climate, and here we look at issues related to weather monitoring, climate modeling, air quality, and also in terms of adaptation planning. And this is quite critical, particularly now with the issues related to climate change. This is a suite of satellite images from different providers, from NASA to ESA to others that I may not mention, but they all have different functions. There are those that are Earth observing, so they monitor vegetation. There are those that are monitoring the gravity. There are those that monitor weather. There are those that monitor the atmosphere itself. So there's a whole suite of different Landsat, and in all this we have data integration where you can be able to use a mix of different, whether it is weather, land-based and ocean-based satellites, or you can use one particular kind. So my focus will be on Landsat data, and this is a whole suite. You can see there's from all the way from Landsat 1 to Landsat 9 currently. Landsat 6, unfortunately, it failed the day it was launched, so the others are still, you can still be able to get images from them. Okay, so I want us to start particularly for the beginners from here to understand the concept of why do we even get images? What is Landsat imagery to begin with? So it starts from the sun, and it also relates to the sensors. So the sun is what provides energy. Landsat in itself does not, the sensor is an optical sensor. It doesn't have its own source of energy, so it relies on the sun to get its energy. So how it records information is that when the sun sends this information down to Earth, it's supposed to be sent back. So the satellite records this information, and how this sun's energy interacts with different things on the ground makes the sensors to be able to record different energy levels. So these energy levels and how much they take to get back to the sensor is what now helps us to discriminate between different objects. Now the sensor then communicates to ground stations. You can see a ground station here in terms of sending the information that has been recorded on the satellite. So at the ground station level, then we're able to process and get what we call Landsat imagery and distribute it through other ways. We have actually the sensor on the left side. This is a sensor at RCMRD that receives MODIS and VIRS data. Then once we acquire the imagery, then we get into the interpretation of these images. So a lot of the people who work on remote sensing data deal a lot with imagery analysis. Now, the other thing that is important to understand is the electromagnetic spectrum, particularly because of working with optical sensors, and this helps us to understand from where within the electromagnetic spectrum our information has been recorded. So a lot of optical sensors operate within the visible window to just a bit of the infrared region in terms of recording information, but we also have radar data that records on the microwave side. So I want to leave this there because it's a whole topic of physics to understand these interactions of energy and how that gets to our sensors and to our ground station. So basically, this is how an image looks like. And it is ideally just a record of information in X and Y axis. So depending on the number of bits that are used to record this information, then you're able to record the what we call digital numbers. So the different pixels of energy are recorded as digital numbers, and this is the digital numbers is what helps us to correspond this to different images and objects on Earth. So I have presented different colors here of imagery. It can be a bit confusing, and we'll get to this particularly when we talk about the classification process. These are what we call composites, and what the first image that is black and white, each and every band of an imagery is usually black and white like this. So if it's a single band, we call them panchromatic bands, and it will be just black and white. So you can't get color information from that. But if you have a multi-band, like in Landsat, we have a multi-band. So multi-band imagery will have more than 2 bands, and this can be from 2 to anything else. For Landsat, this band range from the Landsat 5 all the way to Landsat 9 is about 8 to 10 bands. It ranges in that direction. So in the first band that is a bit red, where I'm pointing at, where we have the 432, this is a band combination of band 4, band 3, band 2. And this is very useful, particularly when you want to discriminate vegetation. So this mixing of different bands is very important, particularly for classification processes, because it helps you to discriminate different things on the ground. And you can see each and every composite has a different discrimination that would make you to understand, because when you just get an image like this, unless you're familiar with this kind of images, you may not even be able to understand. But from this mixing of different bands, then you can be able to make discrimination. There's 543 that helps you to discriminate urban areas, for instance. So this is what we have as Landsat imagery. It's multispectral, and this is what I was talking about. It has a mix of bands. So it's like you have several bands stacked together to create one image strip. So this would be different bands. You have each band is independent, but you stack them together. So when you download a Landsat image, one of them will have several bands stacked together. Now, the other thing that is important to know, especially with Landsat images, is which Landsat are you working with, because the different bands as they are layered represent different things. And every time Landsat does a launch, it keeps making improvements. So every time you're working with Landsat, it's important to know which Landsat you're working with, because this will help you to understand the band information and also to understand the different capabilities that you can get from that particular images. So here, this is just a README for Landsat 9. The different improvements that have been done. And one of the things that really stand out is that now Landsat 9, because it's using a higher bit, it has more discrimination of different objects on the ground compared to the predecessors. When you want to acquire imagery, so this is one of the ways you can be able to acquire. If you go to earthexplorer.usgs.gov, then you can be able to log in. You have to register yourself for you to be allowed to access and download the data. If you haven't registered, you can just visualize whatever imagery is available within that particular set of images that are stored. But for you to be able to actually download, then you must be registered. Now, on this other side, you have this criteria that is also quite important for you to understand, especially when you want to access and download data. So for the criteria, some of the things that you will be asked to is if you have a shapefile. So a shapefile is like a bounding, what would I say, like a bounding polygon can be a square, can be an irregular shape, or just anything, but it must have coordinate information within it. So that if you have either that as a shapefile or a KML file, then it will be able to use this information to pick. If you don't have, then you can just scroll to where you are and put in the coordinate information for where you want to collect your data. You can be able to just draw a bounding box around where you want to get your images from. You also need to specify things like cloud information, the date range of where you want to get your information. So like here, this is the predefined area is now it's if you want to specify a particular area, or you can zoom in and just to get a better clarity, zoom in, zoom out to get better clarity of your location. So this particular site helps you to be able to access your data, but there are other providers that have been able to create tools that you can also use to download your data, like Clovis. That's just one of them, but you can access your data this way. There's also data that has been integrated into data cubes, such as the Digital Earth Africa. It has a data cube of Landsat images. So again, there you can be able to access, but you cannot download from the data cube. All right. Now, so where do you get started? The first thing that I usually advise everybody is you must have some background knowledge of remote sensing. You saw me start this presentation with information on the sun and the sensors and the bands. This is very critical information for you to have in order to understand. One is, what challenge are you trying to address? Now, once you address this question, then you can be able to know if, for instance, if you want to work with Landsat, is it going to be suitable for addressing that particular problem? I think when we started this, we started with you giving examples of how you can work with Landsat data. Some of you mentioned land cover change. Some of you mentioned drought monitoring. So this question helps you to understand what is the most suitable image for you to be able to work with. Again, you have to look at the aspects of scale. If your area of interest is very small, Landsat data comes at a resolution of 30 by 30 meters. So if your location is less than that, then definitely Landsat may not be suitable. So you probably have to find alternative imagery. The other questions that you have to ask yourself, particularly when you begin working on bigger projects beyond the 1 pixel, is you want to ask, is this a project you're doing one time? Or is it something that you want to do continuously? And if it is something that has to be continuous, then you look at, is data available? Or maybe you want to go back in time. Was data available? This particular image you want to work with, was data available then? How heavy is this data? Is it something you can store and process within the resources that you have? Is it up to date? You have to look at the cost implications and also look at the element of sustainability. So if, for instance, you're designing something at a national level and you decide, I want the best, I want to work with 30 centimeter, and this is costing your country, let's say $1 million every year. So is it something that your country can be able to sustain each and every year to pay $1 billion just to maintain that particular process? So those are questions you must be able to answer. And then we get into the element of data acquisition. So data acquisition, I've already shown you how you can be able to access the data. Now we are in an era where we have different transitions in technology where people no longer need to download the data itself. You can work within a cloud environment and process your data there and only get your results. So you don't need to extract your Landsat. But should you need to do that, and even when you do need to access it from the clouds, again, there are questions you still need to answer. What is the period of study? Do you need to filter your image always on dates? You need to filter it on location so that you don't process your data and then you find you worked on another country and you wanted to work in Kenya, Clouds is quite an important element, particularly on classification, on land cover classification, because basically for optical data, where there's a cloud interference, you cannot see beyond the clouds. A lot of the time you cannot see beyond the clouds. So this particular area will be recorded as no information. and it interferes with your cloud, with your classification processing itself. So this process of getting rid of clouds is very, very important. Now, you also need to understand your image. And understanding your image here looks at issues related to temporal resolution. So temporal resolution here would be like the revisit time. So for instance, if you're doing a fire monitoring and you want to be able to monitor maybe the start and the, when before it started and after the fire instance, and then your revisit time for that particular sensor, maybe 1 month later, it will take a long time, and maybe the information may not be useful at the end of the next revisit time. So those, you need to know the temporal resolution. The spatial resolution is the smallest unit that that particular satellite imagery records. So here, the spatial resolution would be, for instance, Landsat is 30 meters. There are other sensors that have 10 meters, other sensors have 30 centimeters. So Landsat is free and open, but if you want to work with higher resolution imagery, then of course those ones are chargeable, so you have to pay for them. There is the spectral resolution. So spectral resolution here is from which part of the electromagnetic spectrum is your image collected. The shorter the wavelength within the electromagnetic spectrum your image is collected, the less things you can be able to discriminate from that. So you need a wider, the wider it is, the better for you. And then there's the radiometric resolution. Again, you also need to understand radiometric resolution is like, for instance, the number of tone variation it can be able to record. Then you need to understand the minute you start handling data, the issues of projections and reprojection become very, very critical, because when you're working with data, you probably will not just be working with Landsat alone. And if you have to even put that Landsat into your home coordinate system, it may require that you reproject the Landsat, or it may require that you have to bring this other data set or the Landsat itself into the projection systems of what other data or other existing data that you may have. So you need to understand the elements of projection and reprojection. Then we get to the classification scheme, and classification scheme here in land cover mapping is what exactly do you want to map? So you can be able to categorize your land cover into different schemes, and this can be maybe forest and non-forest. So you can map anything from 2 and above. And above is, it is not unlimited, because the higher the number of categories you want to capture, unless you rely on other ancillary data, then it becomes very difficult to do that from remote sensing alone, because at some point then you start getting the discrimination of pixels then becoming very entangled with each other. So it's not very easy for remote sensing to discriminate at very, very high land cover categories. Then the other thing is you need to understand, because you're doing this from remote sensing, as an interpreter and an analyst of remote sensing, you have to know these things that you want to map, how do they look like from a satellite image? Because whereas you can use, just tell the computer, just classify as it is, that's what we call like unsupervised classification. The computer just does its own stuff and gives you, but it may not be what you want. It may be gibberish in terms of information. So for as long as you need to do anything that requires training, then you must understand your landscape. So how do these things look like from satellites? The other thing that you need to understand is that there are different elements, particularly for visualization, that help you to discriminate different features. Like how would you discriminate, for instance, a forest from a cropland? They do not have the same pattern. You will notice that within a cropland area, there would be certain interferences, very well-defined shapes, and that can help you distinguish from one land cover category to another. There's things like texture, there's shape, there's a tone and hue. Those will be different for different things. You don't expect the tone of a forest to be the same as a house, for instance. So they'll be very different. There is also the elements related to pattern. There is elements related to site. Like for instance, I know Mount Kenya is somewhere that I know. So when I go to that location and I see something that looks like a mountain, it is definitely Mount Kenya, right? And this can be for different things on things that you know. And there's the elements related to association. You can associate next to maybe this feature that I would expect to find next to a house. There's a road. There's also the element of size. So you can find, for instance, maybe a feature looks like a house, but it's so small. And maybe because of that size, then you're a bit skeptical on whether it's a house or not. So again, these are things that help you to differentiate. Now, there's the element related to reference data collection. And we use reference data for two purposes. One being to, this is what you will use as your training data to classify your image. And you will also use this to validate your results. So before you begin the reference data collection, you have to create sample data that you will use to make your analysis. So again, sampling, there are different methods of sampling, can be random, can be simple random, can be stratified, can be a cluster also. And after you've done your sampling, because your sampling is just, it's like it's blank. It doesn't have anything except the locations that you want to be able to collect your reference data from. Once you have that, then you need to collect the information. So how you collect this information, again, there are different tools that you can be able to use. Some tools that are renowned, particularly within remote sensing people, there's a tool called Collectat Online. So Collectat Online utilizes Landsat data, Bing Maps, Google imagery to be able to make discrimination. We also have a tool called TimeSync. So TimeSync, this is another tool that enables you to collect time series information. And then there is the in situ data collection as we know it. So this is where you go to the field and collect data with either your GPS or your mobile. And again, within our mobile systems, we have built different tools through ODK that we can be able to use to collect this data. All right, so now you have your reference data, then you get into your classification. So within the classification processes, you need to also ask, are you going to do a desktop analysis or cloud computing? So if you're doing desktop analysis, there are different software. Some of them are open source, others are not. I've given examples, QGIS, ArcGIS, and the others are, and these are just some of the ones that I've worked with. And then there's a cloud computing. So cloud computing currently, what is open source is Google Earth Engine, but there's definitely others. I'm sure the experts in here know others that they can be able to utilize. Then I talked about the composites earlier. So this composites really is just how you mix the bands to help you to visualize or discriminate different things from your Landsat images. You need to remove clouds and shadows. I indicated how this is important. If you leave them, they interfere with your classification. So it's always good to remove them. Now, when you remove your clouds and shadow, you leave holes. So these holes, you need to fill them. When you're doing one-step mapping, this you will have to do maybe using another image for a very close time period. If not, if you're using time series modeling, a lot of the times, because you're taking, for instance, imagery through a whole year, you'll find that a lot of where those holes would appear have already been filled through the process of trying to filter through like a whole list of images for the whole year. Then you can also work with different vegetation indices to enrich your interpretation. And vegetation indices here, I'm referring to things like NDVI, which is band IR minus R divided by IR plus R. So that's just one of them. They're different. So these things help you to distinguish different things so that when you have, for instance, a woodland area, you can be able to discriminate that from a forest, because with NDVI, the thresholds are not the same for a forest and a woodland or a savanna. So you can be able to make those kind of discriminations. There are some that are, for instance, within GE, they've already, the algorithm itself, they've already integrated so many of these indices that help you to discriminate your classification better. Then the other thing is you need to know which classification algorithm you're going to use. And here there's a whole suite of so many, from random forests to maximum likelihood, to so many of them. Like, it's just a whole suite of different algorithms that you can use. And here again, we need to random forest responds very, very well, particularly within the tropics. So that is what I use mostly. Then
sorry,
once
just,
you
Phoebe, sorry, just to interrupt. You cut out for a little bit. Which is the one you use most often?
random forest.
Okay, perfect. Carry on.
Yes. Okay. Then sometimes when you're working with one-step imagery, you have to aggregate, because you're interpreting one image and then another image, and maybe you want this to be at country level. So you have to bring in your classification and aggregate this through a process called mosaicing. When you're working with things like Google Earth Engine, you probably don't need to do any mosaicing because this is done for you. But sometimes you find, even when you work with Google Earth Engine, when you download, they come in small grids. So you still have to aggregate your grids through mosaicing. Then another important thing is you should always have at the back of your mind, because you're the one doing the interpretation. You collected your reference data, or you know where your reference data falls. You should have an idea of what should my output look like. For instance, if I collected trainings within a forest and said this a forest, I expect that my classification will put that area to be a forest. But if it is classifying it to something else that is not a forest, then definitely there's something wrong somewhere, and I need to check that. So you should always know what to anticipate, because your outputs, if what has come out as a result is what you expected, then probably you don't need to go to the next step of post-classification, because post-classification is an iterative process where you keep reclassifying until you get something that is suitable. Then you get to what we call the validation and quality assurance stage. And here is also where you do accuracy assessment. Remember, I talked about reference data initially. So we use this to classify, but we also leave some of them to be able to validate our results. So if your classification is good, what is recommended for most results is your accuracy levels need to be around 75% and above. Again, you need to check which method. So a lot of the softwares I indicated provide you with tools for doing the accuracy assessment. So you can use those that are embedded within the software. Within Google Earth Engine, also you can be able to do an accuracy assessment and validation process. All right, then we get to presentation of results. So this is another key important element, because unless you're doing this for yourself just to see that it's nice and colorful, you need to present this, use it in a report, use it as an analysis, use it maybe for an article, or maybe to inform a particular decision. So how do you present your results? You can present your results as a map. You can present your result as statistical data, because probably you're trying to influence a particular decision. And you can also present your results by making it publicly accessible for everybody to be able to access your data. And when you do want to display your results publicly, again, here there are different mechanisms that you have to go through to publish your data. You need to know the data sharing protocols. You need to attach metadata. You also need to know which web sharing tools you're going to be able to utilize to share your data. Then there's a step for analysis. So analysis here, you've already done everything. You have created your data. How do I use this? I talked about statistics. You can derive statistics. You can create models from your data. You can create fact sheets. You can integrate this data together with other data. Because sometimes maybe you're looking at your monitoring change and you notice something is happening here, and it's not, you don't want to just rely on the classification itself. just to say that a change has happened. I want to see what was the weather saying, what was the rainfall, what was the temperature, what was, all this integrates all these things. What is people on the ground saying about this location? So you're integrating so many other things. Or maybe I want to know how much have I emitted in terms of vegetation, how much have I contributed to greenhouse gases? So again, those are things you can be able to apply. Or maybe you just want to know, because sometimes when you talk to policymakers, yes, you give them, this is what is happening to our landscape, but to them, they want to know, what does that mean for my wildlife? What does that mean in terms of, I was selling timber for 10 million, how much am I losing, So you want to quantify that as natural capital. Again, you can be able to use the different models to be able to get to this level of quantification. So here we have sample data that we've created. I have worked with 10 countries so far in terms of data creation. So this is just a sample of them. And in these 2 QR codes, we have data we have created for those 10 countries. So I will share this presentation, or if you can access the QR codes, then you can be able to see. We have for both data sets created visualization platforms where you can be able to visualize the data, you can be able to download it, and you can be able to see some very simple statistics. So again, if you want to use the data for different things, feel free to utilize this for us, because it was sponsored by USAID. We give it for free, so anybody can be able to access it. Now, through the mapping experience that I've had, we've encountered challenges with one-step mapping. And part of what comes out is, for instance, if I'm working in 2010 in a dry season, it is very likely for me to, miss the river, because at that particular point when I was taking this imagery, then it was very dry, and 2 weeks later, it goes back to normal. So in terms of trying to counter this challenge, we moved to using Google Earth Engine. And with Google Earth Engine, then if, for instance, we are presenting data for 2010, we work with the entire series of available data for the whole year. So one of the advantages that this has is, one is those very seasonal or very temporal issues, you can be able to resolve them. So if it's a river, it will always appear as a river. The other advantage with time series mapping is then you're able to do more maps at a very fast time. So you're able to create annual data with very, very limited resources. Now, I think I have talked about Google Earth Engine in a bit. I just want to give just a little bit of what it is. So Google Earth Engine, it's free, it's web-based, and it's a tool and platform that you can be able to utilize to do image analysis. If you want to bring in other developers, then you can be able to do interactive development, because the same code you're working with, you can be able to share it with other people to contribute to it. And you can also be able to access your results. The advantage we have with this is you don't need to download your data. You work with your data, you get into the system, process your data, and only download your results. So the other advantage you get with this is you have a whole suite of different data. So it's not just Landsat, you will have terrain data, you will have MODIS data, you will have rainfall data. So in there you have a little bit of everything that you can be able to integrate into your image analysis processes. And this data is updated every day. This also eliminates the challenges we have with processing capabilities, because if you ask most remote sensing people, the kind of machines we use are so expensive. So not every institution can be able to do this for so many analysts if they had those. So GE then, because everything is being done on the cloud and you don't need to worry whether the processing is being done in this city we have with the data center, what is it called? You don't need to worry whether it's being done in Kwanzaa, whether it's being done in California, whether it's being done in South Africa. You don't need to worry about it. You just send your process. In fact, you can even shut down your computer, go home, and wait to get your results. So it's very interactive. You can be able to print your data. You can be able to save, and it has a platform with people. It has a developers forum where you can be able to work with other people to share if you have challenges, if you want. In fact, right now where GE is a lot of any process you can think of, a lot of those things people have already created code. So you very little time you find you have to create your own new code. Most of the time you don't start from scratch. You find if you want to maybe bring in data, there's already a code that is out there that you can just say, I want to bring in Landsat 5, and then it gives you that code that you start with. So you don't start from scratch. A lot of information is already there that you can be able to utilize. Okay. The other advantage we have with GE, one of the greatest challenges that we had is trying to detect changes when they happen. Now, I used a code called LandTrender. It's a change detection algorithm. And what this does, it helps you, it picks, for instance, you can see like different colors. The background is just to show this is a forest reserve in Zambia. And when there's no change, it's no information. But when you see information, it shows you the last year of disturbance. So the ones that are tending to red, orange, yellow, those are very recent changes. Now, where this is becoming a game changer, particularly in terms of detecting changes, is in terms of monitoring things like forest and landscape, is that if something happens and there's images today, I can be able to use a whole time series and tell you exactly when it happened and where it happened. So this, especially when in terms of conservation, it will be important, especially for foresters. If you give, for instance, a concession right, like you have a right to get your trees from here, and they don't take it from there, then you can be able to monitor and say, okay, this is not where you took your concession from. So this is something we're working with foresters to try and integrate into their monitoring processes. All right, in the context of conservation, there's a lot of utility for Landsat data. And one very easy example is, for instance, how our cities grow. I showed you that's a composite when we started for discriminating urban areas. You can just take that, and just by creating that composite alone, you can be able to discriminate how cities are growing. So if a city is growing, you can be able to, without even any analysis, for as long as you have images for different time periods, right? Now, in the second one, where I talk about feed availability, this is a system that we have built at RCMRD called Rangeland Decision Support Tool. And this particular tool looks at how vegetation is changing and the condition of vegetation. And this is done every 2 weeks. So this is information we are sharing with conservancies, and they can be able to know if the animals are going to be strained, and this is animals, both wildlife and livestock, if they're going to be strained, and where there is a burst of resources, then they can also be able to know. So this, in terms of management, is very important, because there's no point in sending your livestock to a place that doesn't have vegetation. You can always use, you can always guide the local people. This is a better area to send your animals. The next system, this has been built by Digital Earth Africa. It uses, the system is called Water Observation from Space. So again, this uses the data cube to be able to tell how water availability is changing. So this is our lake region in Botswana called Lake Ngami, and you can see how water is changing. So again, this is something that you can leverage. This is free and open source data. to see and advise on water availability, how it has been performing on period of time. And this, you will get information for as long as there has been Landsat data. So all the way from the 1980s, you can get information to date. In terms of drought monitoring, and this is just working with images only, you can tell, like for instance, this is a coastal location. In 2014, you can see how the image looks. It's almost brownish, no vegetation. In 2017, it's a bit, green. And I think if we take our country, for instance, Kenya, in the way we've had 4 failed seasons, if I was to look at the images for the last 1-2 years, they are mostly brown like this. And that is a good indication for drought. So this is something you can quickly tell your minister, your boss, or if you need to make a quick decision on what is the status of drought, then it's very apparent. It's something you can use to make a quick decision. Again, also, we're using this for monitoring certain environmental pressures. And particularly for Kenya, we have regions within the arid and semi-arid lands that have an invasion of invasive species. And these invasive species, they sometimes look like, it looks green. They're always green, actually. They look green, but they're not palatable. And they're also putting a lot of pressure on the water resources. So that is another study we're doing. And then on this extreme end, this is another study. This is being done by the Global Forest Watch. And you can see this is just a representation of how we are deforesting. Seems like Kenya is not doing as bad as Uganda and Tanzania, but where we need to be is Sudan. This Sudan has South Sudan. That's where we need to be. So again, these are tools that have been created off Landsat that people can use to make decisions. Decisions related to, do we need to enhance our policies related to conservation? Do we need to, involve the community because the government has been working alone and it's not effective? Who else do we need to bring on board? All right, so I'm almost getting to the end. I think I have talked a lot. So these are some of the publications I've been involved in. A lot of it has to do with land use, land cover mapping, or we've done something on groundwater, but we used Landsat here to check the correlation between rainfall and vegetation. So you can have a look at them, but I've also provided some resources related to GE. If it's a topic of interest, there's a lot. I've provided you with resources and some training tools you can rely on. I've also provided you with resources related to the code I used for change detection. So this was developed by some very brilliant minds from USFS and gosh, where are the other people from? I forget the names, but you can get them from there. I think that should bring me close to the end. Now, I wanted to play this. This is RLC as we take questions, so you can keep typing your questions as they come in. And you can, the RLC is almost diminished right now. It used to be so big. Now it's almost gone. And it's an Earth Engine time lapse that just creates for you a playlist for how images have been changing from year to year to year. So this again is something, a resource you can be able to utilize just to make your presentation more realistic. I think that's it for me.
Thank you. Thank you so much, Phoebe. That was a really comprehensive talk. And yeah, I think it's hard to compress all the information about Landsat and GIS and remote sensing in one tutorial. So this was lovely to have you share a couple of the things. So I'll just ask you a few questions before we close. The first one is, what is the biggest challenge with fulfilling the objectives of using Landsat in landscape monitoring? Is it in the data collection, the analysis, the policy implementation, or the capacity building?
Okay, you want me to respond to that one first?
Yes, yes.
Okay. The data is not a challenge. I think data, it's open. Before, I think the year 2000, you had to buy Landsat. It was not cheap. So until then because it was made to be free and open, then now there's a lot of research going on related to Landsat, and other providers have also followed suit because of that. So data is no longer a challenge because it's there. The only challenge that Landsat has is because it's an optical data, then you will have issues related to clouds here and there. And for some regions, they experience it a lot more than other regions. So in those locations, then it becomes really, really tricky to work with optical data. And this will not just be Landsat, it will be every other optical data that you're trying to work with will have those challenges because it relies on the sun, and it also gets a lot of interferences from the atmosphere. So whether there's clouds, there's haze, all these things will interfere. On the other hand, the radar, things like radar data, the ones that rely on active sensors. I didn't talk about active sensors, but we have sensors that use the sun energy and those that have their own energy. So some of the active sensors, we have radar, we have LiDAR as examples, but radar data is not affected by the atmosphere. So you're able to overcome a lot of these kind of challenges. But again, also a utility for radar, particularly for this region, and by this region I mean Africa, the processing is very different from optical data. So there's quite some capacity that needs to be built around that. We recognize that particular gap, and we were able to create a toolkit to support particularly the forestry related application areas. So there's a toolkit called SAR Handbook. You can Google it. So that provides you with all resources you can be able to utilize for if you want to monitor, if you want to create biomass data, if you want to know about your tree heights, you can be able to rely on that particular resource. In terms of policy, policy is something that takes time to create, and a lot of the times it is how we're communicating to the policymaker. And what we have come to appreciate, particularly as group of experts, we're not very good communicators. Unfortunately, we're not. So we need to get those people who help us to package this in a way that policymakers understand. Because when you do research, we like those big volumes of things, and policymakers will never read that. They won't. So how do you bring in your 300 pages of research to 2 pages of something you can share with a policymaker to make a decision? And in this region, particularly for the Eastern Africa region, and especially for the areas we've worked with, we have seen a lot of research coming out of just the data we've been able to provide. We've also seen this bringing in other stakeholders and other people wanting to contribute to creating data, to making this data globally available, regionally available, even at local scale. And also, sometimes when the Landsat data is not speaking to what you want, again, you create mechanisms, because the policymakers will realize, okay, this is not what I'm looking for. In my country, what I need is high res. Then they are able to avail the resources, because they must be able to understand the challenges you're facing technically for them to be able to avail the resources for you to utilize. So in terms of capacity building, technology is so rapid. Before you learn this, tomorrow there's something else. So you're always on the run, and you have to be that. Unfortunately, there's no, I think it's just something we have to do continuously, keep abreast of how technology is changing and move with it. For us, again, also that creates a challenge, because it's something that we have to do continuously, train. Again, institutions are faced with the same challenges everybody else gets, where you train this person, then they leave the institution. So you have to go back and do the same training again. So it's a cycle, yeah.
Thank you for the answer. So I'll just ask one more question, and then because we are time is not on our side, we'll just close and then we'll have a session afterwards. So a question that was asked during the session, what is the difference between Landsat versus Sentinel data? What's the advantage of using one over the other?
Okay. My provider is USAID and NASA, so I cannot speak ill of Landsat data. However, you can work with any. It's an open ocean of data. You can work with any. I wouldn't say there's an advantage of one over the other. They're just different providers. It's the same way we have Prestige as margarine and Blueband as margarine. In as much as Kenyans, we tend to call even Prestige, Blueband here margarine. I mean, they're different providers, but at the end of the day, what is it that you want? So remember the question I asked first, when you start handling data, what question are you trying to answer? That is very important. And then you look at availability. Landsat has been there since the 80s. So if you want to do analysis that spans all the way from the 80s, you cannot get Sentinel data, even if you wanted to work with Sentinel. So those are some of the questions that you must ask yourself, because that will guide you in terms of what data do I work with. But if your analysis is 2000 going forward, then you can work with whichever makes you happy.
Thank you.
Yeah.
Okay, so we'll close there, and then if you have any more questions, we'll do that after the session. So Thank you so much, Phoebe, for the presentation and the session that we've had with you. And thank you everyone for joining the session. The recording will be shared in a few days and you'll be able to access it on WILDLABS and our YouTube channel. So our next tutorial will be on the 23rd of March at the same time, where Dr. Moses Otiende from KWS will take us through a tutorial on how to select an ivory sampling method to generate intelligence data. So we hope you'll join us, and thank you once again for joining us for this session. Have a lovely day and the rest of your week.